Physical students, today we're going to talk about the error measurement. Now, the question is from where the errors come. Why do we have so many errors? Well, in the language we have so many errors. Now we're going to talk about the errors in the measurement. So, how does errors come? In order to see this, students, how does errors come? I'll show you a picture. So you just see this. Students, what you can see here is basically an instrument which is known as vernier caliper. What's that? Vernier calipers. This is a precision instrument. Engineers use it. There is other instrument which is more precise than this, more accurate than this also. That is screw gauge. What is that? Screw gauge. There are other instruments also. When you talk about astronomical measurement, like the angle will be not even fraction of a minute, but even fraction of a minute also. That is seconds in small angles. There we use other precision instruments. One instrument widely used is this vernier caliper. Students, see here we are trying to measure the disc diameter. These are two legs of vernier caliper. So now the interesting thing is, students, the person who's taking the measurement, his inefficiency, careless, or lack of experience, or his lack of alertness can cause errors. Let me tell you how. See, I cannot move it, but you want to try to understand. He is trying, this is a gear basically, or we can say it's a shaft having multiple kind of gears on this. So he wants to take the diameter of different, different portions of this. So what he has done, he has inserted the round cylindrical, shaft in between the two legs of vernier caliper. Now, students, let's say he wants to measure this diameter, okay? But by mistake, he insert the bigger diameter, this one, within the shafts. So this answer will be increased. This diameter will be increased. Moreover, even if he inserts the same diameter, which is to be measured, he must place this axis of this job. This job axis should be perpendicular to the line joining two legs. Exactly. If it is inclined, imagine what will happen. These jaws will be moved farther. If it is not at right angle to this, so I hope you can understand from here. See, if it is like this, exactly perpendicular, so we will get a correct measurement. But students, if it is inclined at some angle, it will exert some force on the jaws, so the jaws will move farther, giving a wrong diameter. So placement of this, reading of this, then instrumental error. What is instrumental error? There can be a zero error also. Means now see, this is one gauge and this is the main gauge. So the zero of them of both should coincide, though you cannot understand much from here. So zero instrumental errors can also be there. So many errors. So that's why if a teacher asks 6 students, let's say, to measure the diameter of this, they might have different readings. So based upon this error in the measurement, we will define absolute error, then absolute mean error, and the third one is fractional or relative error. Based upon fractional and relative error, we will define percentage. Right? That's all. So guys, let's get back to our page. So error measurement. So first is, students, we talk about, before talking about error measurement, I must talk about least count. Least count basically belongs to an instrument of an instrument. See students, let's talk about a simple scale. You've been using from 4th, 5th standard till 10th standard, simple scale. Students, can you tell me that how does the scale looks like? It's simple plastic sheet kind of thing with a lot of calibrations on this. So if you see, it starts with 0 and then there are 10 divisions and then you get 1 and it's written centimeter here, right? Again, you have 10 divisions, students, and it's written 2 centimeters. So maximum length is sometimes 13 centimeter, 15. If it is a steel ruler, it may be 25 centimeter, maybe like that, right? 25 centimeter. Now, students, the question is, what is the least measurement you can do with a normal scale? This normal scale only, which all the students have in the geometry box. So, students, suppose this is the length. Let's say this length is 1 centimeter. Can we measure this length with this scale? Yes, we can measure it. We'll put one side, one end of what we want to measure here, other end here, and we will say this is 1 centimeter, right? If something is, what is the maximum length you can measure? It is, in this case, it is 13 centimeter. Now, what is the minimum, the least measurement you can do with this? Yes, can anyone answer? What is the least measurement you can do with this? What centimeter? Beautiful. So Ishma Anand is correct. You see, I'm going to magnify this. This is 1 centimeter. Now 1 centimeter is divided into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 parts. Obviously, if some length is this much, that means this length is 1 mm. So placing the two ends of that length over these dots, we can definitely measure 1 mm. Students, if you have a length of 0.5 mm, it will be completely filled with uncertainty. In other words, I will say you cannot measure 0.5 mm with this. If you're very smart and your eyes are perfect, you might place that thing exactly in the center of it and approximately say this is 0.5 mm. But still, you cannot actually say it is 0.5 mm because 1 mm is further not calibrated. But 1 centimeter is calibrated. So the least count of a simple scale is simply 1 mm. So students, this is important for you to understand. Least count, we have understood. And then students, we go for absolute error. Absolute error. Absolute error. What is this? Now let's say again, this is a shaft. This is a shaft, right? And I have given this shaft to basically 6 students, right? This is a shaft. And I've given this shaft one by one to 6 students, right? Now I want the students to find the diameter of this shaft. So one student in the legs of the vernier caliper, he could be an intelligent student. He might place it approximately in the same manner and he will do the measurement. The second student may be a little careless, so he might place the shaft like this at an angle. Now what will happen? There'll be a force on these limbs, slight force, which will give you erroneous measurement. Similarly, students, there can be lack of experience on the student's part to take. There's a particular way to add or subtract the least count and then get the right value in vernier caliper. If he doesn't know that, so it's quite possible that all the 6 students might get little error in their measurement. So what is the exact diameter? What is the real diameter? What is the true value? That is the question which prompts us to discuss about error measurement. So see that student, this question will be answered. Now, let's say these 6 students have taken the measurement A1, A2, A3. Jasmine, please speak. The last one is AN. Right? You can replace. You can say A1 is. So basically, what is A1? A1 is the diameter of shaft as recorded by first student. Right, Jasmine? Are you able to understand?
Yes, sir.
Good. What is A3, Jasmine? A3 is the diameter of the shaft as measured by
Second student.
third student.
Third.
Now, what will be, no, let's say it's A6. So what is A6, Ishma?
Diameter of the shaft measured by the
Measured by the 6th student. So, do you really think all the students will have same measurement? Almost impossible. Never possible, right? Why? Because the experience level, the focus, the trainings, and the state of mind of all the students at the time of measurement will be different, giving error in their measurement or results. So students, now the question is, all these measurements are little different. Now, what is the true value? Or you can say, what is the actual value of diameter? Now, there are two cases. Sometimes the actual value is given. So that he says it is A. All right. Sometimes we need to do the experiment. We need to find out the actual value. We have taken 6 measurement. We will say our actual value or our actual diameter, or you will say our true diameter is the mean or average of all these 6 diameters, or you can say 6 observations, right? So students, what will be our actual diameter, or you can say our true diameter? Let's say that is AM, means AM. So what will be AM? We will find mean of all these values. So what will mean of all this? Jasmine, it will be A1 plus, A2 plus, A3 plus,
A3
plus
dash dash dash
the last measurement is A6. We
A6.
take all the 6, just like we know little bit about statistics in 10th standard. So we will divide this. These are all the observations divided by number of observation. Number of observation is 6, right?
6.
So this value we will be AM, and in scientific notations we sometimes take AM as the actual diameter, or you can say AM as the true diameter. All right, students, let's go. So this is done. So have you understood, Jasmine, that either the true diameter will be given, or if it is not given, we will take AM, that is mean of all observations, or the average of all observations as the true value. True value. Okay, Jasmine, this is the true value. What are the measured values? Jasmine, can you tell me what is the measured value by 4th student? A4.
A4.
The measured value, measured diameter by first student? A1. Similarly,
A1.
A2 is the measured value by second student. A3, A4, A5, and A6. These are all the 6 measurements we have by different students. Now, you know, all the students have some error in their measurement. Is it clear? Now, the question is, what is the error in the first measurement? That we will represent as, what is the error? Okay, suppose the actual length of some pen is, let's say I'm giving a pen to students to measure. Okay, Jasmine, let's say the actual length of pen is 11.2 centimeter. I asked some student to measure it. He says it is 11.1 centimeter. So, so Jasmine, what is the error in his measurement? This is the actual value. Suppose this is the measured value by the student. Then what is the error? Anyone?
0.1.
Correct. Error is, you know the true value is 11.2 centimeter minus whatever he has measured. So that is 0.1 centimeter is the error. Am I right, Jasmine? This error is
Yes, sir.
known as absolute error. So absolute error. Now we get the definition of absolute error. What is that? Come on, students. Anyone can give me definition of absolute error?
The difference of the
So it is true value minus, yes, Jasmine? Can you tell?
Minus error.
No, not error. We want to calculate the error. So 11.2 centimeter was the true value and 11.1 was the measured value by the student. So error is true value minus measurement, or you can say measurement, or you can say measured value. Very good. So this is represented by delta A. Okay. So there will be how many errors? 6 measurements means 6 errors. So now, Jasmine, what will be the error in the first measurement? That we will write as delta A1. So yes, Arjinder Khan, can you tell what will be delta A1? True value. But true value, let's say, was not given. So let's say we have taken the mean, not let's say. Actually, we have taken mean value as the true value. Subtract. See, he's asking the error in the first measurement. Then you will subtract the measurement of diameter taken by the first student. This is A1. Got it? Similarly, we will have delta A2 is equal to AM minus A2, right? And we will have delta AN. Sorry, in this case it is 6 is equal to AM minus A6. So students, the value of delta A can be positive, can be 0, can be negative, depending upon. Again, see the example. Jasmine, listen carefully. See, but in this case, what was the actual length of the pen in this case? In this case, what is the actual length of pen? Actual length of pen is 11.2 centimeter. Okay. Now the student has measured the length of pen as 11.1 centimeter. Now what is the error? Absolute error. Delta A.
0.1
Yeah.
centimeter.
True value. You always say formula first. 11.2 minus 11.1. So that is equal to 0.1. What? See, one more.
Centimeter.
Jasmine, the units of true value and the units of absolute error are always same. Otherwise, it is shame. So it is 0.1 centimeter. Am I right? Okay. So other student may be very smart, and he knows how to operate the least count measurement, vernier caliper. For a long time he was visiting lab, so maybe his measurement is 11.2. Actual true value is also 11.2. So Jasmine, what will be the absolute error in that student case? The true value is also 11.2.
No error.
Correct. You are right. So his error will be 0 centimeter. So this is the second case. Absolute error is 0. Now there can be erroneous student. He has measured 11.3 centimeter. In this case, the absolute error will be minus 0.1 centimeter. That's what I said, students. The delta A absolute error can be positive, negative, and 0 depending upon whether the measured value is less than true value, equal to, or more than true value. Students, now I talk about something different. Mean absolute error. First I talked about absolute error. Okay? Mean absolute error, students. This is delta A1 was the absolute error in the first measurement. I will take modulus of this. Modulus of something is always positive. Then I will write delta A2. Ajinder Kaur, what is delta A2? Absolute error in the measurement of second student. And I will take delta AN, in this case A6, divided by 6. That means mean of absolute error is known as mean absolute error, represented by delta A mean. This is very, very important, delta A mean. So students, now can you tell what will be the maximum value, maximum observed value will always be AM, true value or mean value, plus delta A mean. And what can be the minimum measurement taken by any student? That will be AM minus delta A mean. So can I say all the observations, students, or all the measurements in any experiments will vary between AM minus delta A mean, A, and yes Ishma, AM plus delta A mean. This is how, oh shit, sorry. So the measurement will be in between this range. Having done this, students, I talk about the last type of error. What is that?
Relative.
That is fractional error, or it's known as relative error. Well, that is equal to, yes, plus minus, I think it's delta A mean divided by AM or A mean. What is that? It is the ratio of mean absolute error divided by true value. Mean absolute error divided by true value. Students, if I multiply this by 100, I get percentage error. Students, I wish you all the best. Don't forget to like and subscribe our channel. Learn CBSE. Share with your friends. Wish you all the best.